Hi, welcome to online BWE course. I am M. Prashant in GRIT from Triple E department. In this video, I will discussing about Thevenin's theorem and Norton's theorem. Thevenin's theorem. It states that any two-terminal linear network having a number of voltage, current sources and resistance can be replaced by a simple equivalent circuit consisting of single voltage source in series with resistance, where the value of voltage source is equal to open circuit voltage across the two terminals of the network, and resistance is equal to equivalent resistance measured between the terminals, with all the energy sources are replaced by their internal resistance. So consider one circuit. So here 10 ohms voltage source connected to 2 ohms resistor, here 12 ohms and 24 ohm resistors are connected in parallel. So total 3 passive elements, one active element is there. So calculate voltage uh, through 24 ohm resistor by using Thevenin's theorem. So normal method, voltage distribution and current distribution. Calculate current through I24 is equal to 1 ampere, and voltage I total is equal to 1 ampere, and I current through 24 ohm resistor is 0.33 amperes by using current to distribution law. And calculate the voltage across 24 ohm resistor is equal to current into resistor, that is equal to 7.92 volts by using normal method. So here by using Thevenin's theorem, calculate the current and voltage through voltage across 24 ohm resistor. So according to Thevenin's theorem, so total network is converted into single voltage source and single resistance. So that single voltage source is called as Thevenin's voltage. So for calculation of Thevenin's voltage, simply uh, that terminal is that resistance is replaced by open circuit. Calculate that open circuit voltage. Remove that 24 ohms resistor. Calculate open circuit voltage across the terminal A and B terminal by using any method, any reduction method. So here voltage across 12 ohms is equal to open circuit voltage. So here 2 ohms and 12 ohms are connected in series. So in series circuit voltage is distributing. So by using distribution law, calculate voltage across 12 ohms. So is equal to the VThevenins. That VThevenins is equal total voltage into same resistance by sum of the resistance voltage as per distribution law. So same total voltage is 10 volts. So same resistance is 12 ohms by sum of the resistance means 12 plus 2. Calculate this value, we get 8.57 volts, that is the VThevenin's value. Voltage across A and B, terminal A and B is equal to open circuit voltage VOC, that is equal VThevenin, that is equal 8.57 volts. Next, calculate the RThevenins. At the time of RThevenins, remove the calculated resistance 24 ohm resistor and open circuit. Next, active elements are replaced by internal resistance means voltage source acts as a short circuit, current source is taken as open circuit. So in this circuit, 10 ohm voltage source is there, that voltage source is taken as short circuit. 24 ohms resistor is taken remove, and open circuit, consider as open circuit. Calculate equivalent resistance across terminal A and B is equal to R Thevenins. Thevenins. So here 2 ohms resistors and 12 ohm resistor both are connected in parallel. Both are connected in parallel. According to mm, parallel circuit, R equivalent is equal to, for two resistance, R1 R2 by R1 plus R2. So here 2 into 12 by 2 plus 12. So calculate equivalent resistance is 1.71 ohms. Now, so total circuit is replaced by single voltage source in series with the resistance. That voltage is the Thevenin's voltage, that resistance is Thevenin's resistance. Already we calculated V Thevenins and R Thevenins, substitute in this circuit. Now load element 24 ohm resistor is connected to that terminal A and B. Now calculate the current through 24 ohm resistor and calculate the voltage across 24 ohm resistor. So here voltage source connected in series with the Thevenin's resistance and 24 ohm resistor. So these two are connected in series. These two are connected in series. So in series circuit, R equivalent is equal to R1 plus R2, R Thevenin plus 24 ohms. So in series circuit, as per voltage division rule, calculate voltage across 24 ohm resistor is that is the one method. So another method is calculate R equivalent and calculate the I total. So I total means current through 24 ohm resistor. Here I total current, same current is flowing through R Thevenin's and I24 24 ohm resistor. That's the reason I24 is equal simply V Thevenin's by R Thevenin's plus 24. So first calculate the current through 24 ohm resistor, that is equal 0.33 ohms. Next voltage across 24 ohms is equal to current through that resistor into 24 ohms resistance value. So we get 72 wrote 72, but this value is 7.29 volts. So Thevenin's theorem is verified. So according to voltage distribution and current distribution law, calculate the current through 24 ohm resistor and voltage across 24 ohm resistor is same as the Thevenin's theorem values. So Thevenin's theorem is verified. Next, problem number 2. So determine the Thevenin's equivalent circuit across terminal A and B. So this A and B. Voltage across this terminal A and B. So first calculate the V Thevenin's value. Calculate that voltage value by using nodal analysis or mesh analysis. Any another method, calculate that value. We get some so first calculate the V Thevenin's value. At the time of V Thevenin's, so both the sources are active position, active. So calculate the current through 10 ohm resistor. Here A and B terminals are open circuit, so no current is flowing through these terminals. So current is flowing through directly 10 ohms to 5 ohms and 20 ohms to 25 ohms source to 50 ohms source. So same current is flowing through 10 ohms and 5 ohms. So that two are connected in series. So current through these two resistance is equal to 50 minus 25 by 15. So current, we calculate the current I is equal simply 25 by 15, that is equal to 1.67 amperes. 1.67 amperes. 50 minus 25 by 10 plus 5, that is equal to 25 by 15, that is equal to 1.67 amperes. Next, calculate the V Thevenins. V Thevenins is equal to apply nodal analysis at this point. So we don't know this voltage. Assume this voltage equal to V Thevenins, because VAB is equal to open circuit voltage, VOC is equal to V Thevenins, that is same as this node voltage V Thevenins. So here apply KCL in this at this node. So V Thevenins minus 50 by 10 is plus V Thevenins minus 25 by 5. is equal to 0, because sum of as per KCL law, sum of entering currents is equal to sum of leaving currents. Here no entering currents are there, both are assuming leaving currents. uh, Current through 10 ohms resistor is VThevenin minus 50 by 10, plus current through 5 ohms is VThevenin minus 25 by 5 is equal to 0. So calculating one unknown quantity is there, so one equation is enough. So calculate voltage value V, that is equal to VThevenin, we get 33.3 volts. 3 volts. So next, R Thevenins. At the time of R Thevenins, both the sources are replaced by internal resistance. So voltage source internal resistance is 0. So that's the reason voltage source is taken as short circuit. Now 10 ohms and 5 ohms are both are calculate the R Thevenins. R Thevenins is equal to RAB, equivalent resistance between terminal A and B. That is equal to R Thevenins. Now 10 ohms and 5 ohms, these two are connected in parallel. So calculate R equivalent. R equivalent is equal to 10 into 5 by 10 plus 5. Calculate the R Thevenins is equal to 3.3 ohms. Now equivalent circuit is VThevenins in series with the R Thevenins. Here VThevenins value is 33.3 volts, is connected in series with the R Thevenins. R Thevenins value is 3.33 ohms. Next, Norton's theorem. It states that any two-terminal linear network with current source, voltage source and resistance can be replaced by equivalent circuit consisting of single current source in parallel with the resistance. The value of current source is the short circuit current between terminals of the network. Resistance is the equivalent resistance measured between terminals of the network with all energy source replaced by the internal resistance. According to Norton's theorem, equivalent circuit found from this shown. Consider this circuit. Here 20 ohms voltage source is there, 5 ohms, 10 ohms and 6 ohms, 3 resistors are there. So here 10 ohms and 6 ohms are connected in parallel. So equivalent resistance is connected in series with the 5 ohms. So first calculate the, as per voltage division rule and current division rule, calculate the current through 6 ohms resistor and calculate the voltage across the 6 ohms resistor. So current is 1.43 amps here, voltage is 8.58 ohms, 58 volts. Now calculate the current and voltage across 6 ohms by using Norton's theorem. As per Norton's theorem, 6 ohms resistor removed and short circuited. So calculate the this short circuit current is same as Norton's current. Calculate that Norton's current for this circuit. So here 10 ohms is short circuit. 10 ohms is connected across short circuit. So no current flowing through the 10 ohm resistor. So same ion current is flowing through 5 ohm resistor. So calculate the current through 5 ohms is same as the ion. So that I5 is equal to voltage by resistance V by R. I is equal current I is equal to V by R. So that is equal 20 by 5 ohms. We get current I is equal to 4 amperes. That I is equal to IN. IN is equal simply 4 amperes. Now calculate the R Nortons. So R Nortons is same as the R Thevenins. So R Thevenins, at the time of R Thevenins, these two terminals are connected in short circuit. Not short circuit. So this is the this 6 ohms resistor is removed and internal voltage source is replaced by internal resistance. So here voltage source internal resistance is 0. So voltage source is taken as short circuit. Now calculate the R Nortons between terminal A and B. So RAB is equal to R Nortons. So 5 ohms and 10 ohms both the resistors are connected in parallel. So according to parallel formula, calculate the R Nortons. 5 into 10 by 5 plus 10, that is equal to 3.33 ohms. Now the total circuit is converted into replaced by norton circuit.